Hi guys, क्या हाल चाल है भाई? Hello everybody. Uh, Namaste, and this is Saurav Goswami. Welcoming you again on the Catalysis channel of Vedantu, and we are discussing hydrogen as the topic for 11th standard kids. So if you are studying in 11th standard, we are discussing inorganic chemistry. First topic, that is hydrogen. Please. Uh, Hello everybody who has joined us right now. Meghna, hello, hello Arati, hello Nishrit, hello Pratik, hello. How to get a good Naveen Raghav? You have to study, man. Hello Lakshmi. Nishrit, we are currently doing inorganic chemistry, so let's focus on that. We are currently doing inorganic chemistry, so let's focus on that. So when the time comes, Pahul sir has already discussed a lot of videos, already posted a lot of videos on physical chemistry. Okay, so let's focus on inorganic chemistry. Okay, thank you, Real Truth. Okay, hello Devakar. Okay, so if you recall, yesterday we had started a topic known as hydrogen, which is the potato of inorganic chemistry. Goes with everything, goes with every other element, binds with non-metals, and today you will see that how it binds with metals. Okay, so hydrogen is a very important topic, important in the sense that you will get at least one question in mains examination, at least one question in NEET, at least one question in JEE Advanced. In JEE Advanced, they give questions from hydrogen, and almost every alternate year they will put a question from hydrogen topic. Okay, I will be covering DNF block as well. Yes, I will be covering DNF block, but that DNF block is a part of 12th standard syllabus. So if you're in 12th standard, join us at 9:30. Okay, or join me at 9:30. Okay, chalo. So let's start today's discussion. And just a moment. Yup. So yes, let's start today's discussion, and we are still at amazing hydrogen, and we know that hydrogen is everywhere around us. Everything which we can see, perceive, has a bit of hydrogen in it. Hydrogen, even if it is not in the portion of advanced, questions will come from it. Okay, please check. Questions will come from it. There is no limitation to from where questions can come. Okay, it is a very relatable topic, so questions can come. So yesterday's session we had learnt about the preparation of hydrogen. Okay, and the last thing that we had discussed was that preparation of hydrogen by adding active metals to acids. Okay, we had discussed this, adding active metals to acids, and I had told you that there's something known as the reactivity series, in which metals above hydrogen will displace hydrogen from acids, isn't it? Metals above hydrogen will displace hydrogen from acids. Okay, displace hydrogen from acids. Clear? Less reactive metals will not displace hydrogen. So let's go further. I had also told you that those metals which are capable of forming amphoteric oxides can react with sodium hydroxide to liberate hydrogen. Like aluminium, zinc, tin, beryllium, all these metals form amphoteric oxides. Amphoteric oxides are those oxides which can react with acids as well as bases. These can react, these metals. So remember, metals which form metals which form amphoteric oxides will liberate hydrogen from bases or from alkali. Okay, clear? This is for class 11th. Yes, class 11th. Yes. Okay, chalo, let's move further. So as I had told you that we have to remember the reactivity series. And how do we remember the reactivity series? Please stop calling me a careless zebra. Instead, try learning how copper saves gold. Okay, please stop calling me a careless zebra. Instead, try learning how copper saves gold. Okay, so potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold. So copper, silver, gold will not displace hydrogen from its compounds. Things which are present above will displace hydrogen from its compounds. Okay, now how do we prepare pure hydrogen? If I want to prepare pure hydrogen, then there are certain methods, and these methods, like the previous methods that we have obtained, might have a lesser concentration, lesser percentage purity of hydrogen, but these methods give pure hydrogen. The first among them is the metallic hydride reacts with water to form alkali and hydrogen gas. So what is metallic hydride? A metallic hydride is a hydride. First and foremost, what is hydride? A hydride is a substance. Pure hydrogen means where the percentage purity is higher. Okay, so hydride is a substance where hydrogen is connected to a metal, non-metal, or a transition element metal. Mostly, if I say metallic hydrides, I am taking those hydrides which are of group 1 and 2. Can you see this? Lithium, sodium, calcium. These are hydrides of group 1 and 2, and these hydrides are known as ionic hydrides. So just not writing metallic hydrides is enough. Writing ionic hydrides, okay? Writing ionic hydrides is important. Ionic hydrides will react with water, will liberate hydrogen gas. Clear? Ionic hydrides will react with water, will liberate hydrogen gas, and in this process they will form alkalis. LiOH, NaOH, calcium hydroxide. Okay. Another method is UNO method. UNO method is simple. You take scrap aluminium and react at the base. Okay. Take scrap aluminium and react it with a base. So what you are getting is a aluminate. AlO2 is a aluminate salt. You are getting a aluminate salt, and it is liberating metallic or ionic hydride. The right way to write this is ionic. It should be written as ionic. I have told you that it should be ionic hydride. Ionic hydrides react with it. Okay. Metallic hydrides are generally written as to be those hydrides which are formed using the transition metals. Transition metals are those metals which are in the D block. Group 1 and 2 metals form hydrides, and these hydrides are gonna react with water to liberate hydrogen. What is a scrap aluminium? What is scrap? Waste. Not that great. Corroded aluminium. Okay? Hello. Okay. So the second method is also done. First method is done. The third method is addition of H2O on hydrone. Hydrone is a alloy of sodium and lead. Please do remember hydrone. Hydrone is an alloy of sodium and lead. hydrone is an alloy of sodium and lead. I had told you yesterday that what is the purpose of using an alloy is because sodium will react very, very rapidly. Sodium can do an explosive reaction with H2O, and to avoid this explosive reaction, we combine it with other metals and to reduce its reactivity. Remember that sibling and you example where your sibling is very naughty, and to prevent it from causing any nuisance, your parents send you with your sibling to every party that he or she is attending, because then you will have a bit of a control on him. So hydrone is also an alloy. Hydrone is also an alloy. Metals mostly form hydroxides. There is no metals can form Na and Pb, but my name is hydrone. See, there are so many ways names can be given. Okay, there are so many different ways names can be given. Your name is dependent on something else which is not exactly dependent. So like bronze, it's an alloy. So alloys names are not exactly what brass. Brass is a trade name, it's a commercial name, so it is a commercial name. Okay, so don't worry about it. The alloy is hydrone, it's an alloy of sodium and lead. That is something that you have to remember. Okay, chaliye. Hello Monica. Now any preparation of pure hydrogen is incomplete without electrolysis. And electrolysis of barium hydroxide will cause production of hydrogen. Okay, so hydrogen in high purity is obtained by electrolyzing warm barium hydroxide between nickel electrodes. And how do we obtain hydrogen? So what happens is, your OH minus, whatever OH minus that you can see from here, this OH minus will undergo oxidation. OH minus will undergo oxidation. Okay, it will undergo oxidation, it will produce O2 plus half H2 plus electron, half O2, half H2 plus electron. So this is how the reaction will take place. This will undergo oxidation and will produce hydrogen gas. Okay, is that clear? This will undergo oxidation. So please do remember that when you are electrolyzing a solution of barium hydroxide, then OH minus will go, and where would this reaction take place? This reaction takes place at anode, because at anode oxidation reaction occurs. So high purity 99.95% is obtained by electrolyzing barium hydroxide. Clear? Chaliye. The other process, industrial method of preparation. Lane's process is industrial method. So the Lane's process, which is industrial method of preparation, utilizes iron, and it utilizes steam, superheated steam. We can use barium hydroxide is easily available. You can use sodium hydroxide as well. That's not a problem. Okay. So as I told you earlier, if you look at the metals in the reactivity series, the metals present above hydrogen will obviously react with water, but some metals will react with cold water, some metals will react with hot water, and some metals will react with steam. So iron is one of those metals which will react with steam. So if you take sodium, potassium, calcium, they will react with cold water. they can react with cold water. Lead will react with hot water. And iron will react with steam. Okay, iron will react with steam. I'll get to Bosch process a little later. Understood? So we'll discuss Bosch process this after this. So iron will react with steam, and it will produce Fe3O4. Okay, Fe3O4. Fe3O4 will be produced along with hydrogen gas, and this process will give out some amount of heat, that is 1607 kilojoules of heat. Then what we do is the reduction step, where iron is regenerated by reducing Fe3O4 by any reducing gas. So anything which can reduce, so Fe3O4 can be reduced by H2, Fe3O4 can be reduced by CO. So there are two steps of this process. One is production of hydrogen, one is the regeneration of iron. Okay, two steps are involved: production of hydrogen, and then regeneration of iron. Okay, what is the charge on hydrogen? How can the charge on hydrogen? Hydrogen is a neutral entity. Hydrogen will have zero charge. H, if it is H, it can be plus or it can be minus. But if it is H2, it will be neutral. Okay, clear? Sure. Now let's discuss the chemical reactions. What are the chemical reactions of hydrogen? Okay, what are the chemical reactions of hydrogen? The chemical reactions of hydrogen are very easy to understand. So I have given a flow chart. Okay, in this flow chart you can in this arrangement, in this grid, you can see that hydrogen is reacting with certain species. It starts by reacting with, we start by understanding that how it reacts with oxygen. So hydrogen will react with oxygen to give H2O, and it is not highly combustible. This process is highly exothermic. This process will liberate a lot of heat, and this process is responsible for generation of water, which is required for the sustenance of life on this planet. Hydrogen will react with metals to give hydrides. These are ionic hydrides. Hydrogen will react with halogen, and halogens will react with hydrogen with different reactivity. Like hydrogen will react with halogens in such a way that fluorine's reactivity is maximum and iodine's reactivity is minimum. Why fluorine's reactivity is maximum and iodine's reactivity is minimum is that later you will study that the reaction of H2 plus X2, where X is fluorine, chlorine, bromine, iodine, is known as a free radical reaction. Free radical reaction. A free radical reaction takes place violently or takes place very rapidly with fluorine, because fluorine free radicals are represented like this: F with a dot, F with a dot, Cl with a dot, Br with a dot, I with a dot. These are free radicals. These free radicals are most reactive when the radical is present on a electronegative element. So radical, if is present on an electronegative element, the reactivity increases. So F free radical is most reactive, and that is the reason F2 can react even in dark chlorine reacts in diffused sunlight, bromine requires 670 Kelvin and iodine requires 670 Kelvin plus platinum. Clear? Please tell me yes if you have understood this. That because fluorine is so reactive, fluorine can react even in dark, chlorine can react in diffused sunlight, bromine can react at a needs to react at a higher temperature because it is less reactive, and iodine will react at a higher temperature but with platinum in the medium. Iodine is also electronegative. However, the electronegativity of iodine is very less. Okay, electronegativity of fluorine is very high. Okay, electronegativity of fluorine is very high. Understood? Chalo. Okay, clear. Now, there is a process known as Haber's process. I hope you know about this. Haber's process. Haber's process. What is Haber's process? Haber's process is where hydrogen reacts with nitrogen to give ammonia. Okay. Why do we need platinum? We need platinum. Catalysts are utilized in those reactions where the reactions is extremely slow. If I use a catalyst, then the reaction will become fast. Okay. If I use a catalyst, then the reaction will become fast. Understood? So it's just like, suppose you are given a task and you have to finish that task in the shortest span of time, and you are usually a laid back person, you're usually a lazy person, you don't like to work really hard, then what will happen is the person who has assigned you a task will put a catalyst. He will put a supervisor over there. That supervisor will keep on checking on you that whether you have completed a task, something like that. So the platinum is okay. See, Lavanya, you have to understand that tricks do not work in final examination. Okay, tricks do not work in final examination. Tricks, if you want to get a really good rank, I have been teaching the toppers batch and the champions batch earlier as well for quite a long time. Let me tell you something. If you want to get a very good rank, if you want to get to the best college in the country, tricks do not work. Everything has to be done from scratch. Tricks is something which you improvise. So helicopter shot of Dhoni is something which he has improvised because he knows how to bat. He knows that how to play. Okay? Is that understood? So tricks are something that you will identify. Do you think that Sachin Tendulkar was taught all those tricks to be the one of the best cricketers that India has produced till date, or the world has produced till date? Do you think his coach has taught him all of that? No. Okay, the coach hasn't taught all of them. Sachin Tendulkar's coach just gives the idea, the learner improvises. Okay, so tricks you will identify, but let me tell you, tricks do not work in final examination. What works in final examination is your preparation, is your solid preparation. Okay, chalo. So H2 plus N2 gives NH3. Tricks, obviously they'll come with practice. So H2 and N2 will give ammonia, and that's known as Haber's process. It uses the catalyst iron and uses molybdenum as a promoter. H2 can react with carbon, but this reaction is highly I would say it's not a very favorable reaction. It requires a very high temperature because carbon is fairly unreactive. Okay, carbon is fairly unreactive, and that's the reason it requires a high temperature to convert into CH4. When it reacts with sulfur, okay, now if you look at carbon and sulfur, carbon is present in the second period, sulfur is present in the third period, sulfur is slightly larger, so the tendency for the electrons in sulfur are slightly lesser, are held under lesser attractive force. Carbon is smaller, so its electrons are held under higher attractive force. For that reaction, for reacting with carbon, a higher temperature is required. For reacting with sulfur, a lower temperature is required. Okay, hydrogen will react with cuprous oxide, sorry, cupric oxide or cuprous oxide even. It will reduce them to copper. So hydrogen will reduce metallic oxides into their respective metals. So you can see that metallic oxide is taken, it will reduce it to free metals. And I hope you have learned about this. Hydrogen can react with alkynes, or hydrogen can react with hydrocarbon, unsaturated hydrocarbon, to result in the formation of saturated hydrocarbons. Kunal Chaudhary, I'll get to that. Why do some metals of group 2 form covalent hydrates? I'll get to that. Just give me a moment. Sir, what is parahydrogen? We had discussed this yesterday. Parahydrogen is that hydrogen in which the spin of the nucleuses of two hydrogen atoms is different. Okay, they're in opposite direction. Ortho has same okay. Can process be performed without catalyst or by manipulating? Yes, we can do it. But what is the role of catalyst? Catalyst lowers the activation energy. You will learn this in chemical kinetics, or you can watch the videos of chemical kinetics that Paul sir has put up. Chemical kinetics says that every reaction requires a certain energy to happen. If this energy is very high, then the reaction will be very slow. So catalyst provides an alternate pathway for this reaction to take place. Okay, for example, let's say you are investing a lot of time in getting the tickets for a movie. Okay, you are running for pillar to post, you are going to all the different web pages to get a ticket for a certain movie. Let's say lockdown, this corona ends, and corona ends as soon as possible, and you want to see a movie in the theater because you had been in the house for quite a long time. Now you are trying to get the ticket, you're not able to get the ticket. Okay, but suppose you getting the ticket has a very, very high activation energy. You are not able to get the ticket. So what happens, suppose it comes, you come to know of the fact that some uncle in your apartment works with Book My Show or works at a movie theater. So you will go and tell him that, uncle, please, I want to watch a movie. So he might arrange it for you. So that uncle turns out to be your catalyst. He decreases the amount of effort that you have to put to get that ticket. Okay, yes, Kruti, yes, I will be following this up with some questions. Yes, let's start with this one. Okay, let's start with this one. Metal which does not react with cold water but treated with steam evolves hydrogen gas. Okay. Okay, metals which does not react with cold water but treated with steam evolves hydrogen gas. Treated with steam gives hydrogen gas. Please tell me the answer in the chat box. See, the right answer is given by a lot of people. The right answer is iron, Fe. देखो, sodium and potassium will react with cold water. They will react with cold water. They are very reactive. They react with cold water. So they are very reactive. They'll react with cold water. Okay. This platinum guy is below hydrogen in the reactivity series. It is below hydrogen. So it will not react with cold water. So this is below hydrogen. This is below hydrogen. So this platinum guy, okay, platinum guy will not react with any compound and displace hydrogen from it. Any hydrogen containing compound and displace hydrogen from it. So this will not react at all. They will react, but they will react with cold water. But iron is above hydrogen, but not so above, not as high as where sodium and potassium is present. So iron requires superheated steam. Iron requires superheated steam or steam for reaction. Okay. So, but treated as steam evolves hydrogen gas. The right answer is Fe. Arey, radium is radioactive, man. We do not study, at least in the level of 11th and 12th, we do not study the chemistry of radioactive substances other than learning about radioactivity, which is like not a chemical process per se. It's a chemical process, but not like a reaction is occurring where two things are combining with each other. That is not happening over there. Something is disintegrating. That's a different science altogether. We do not take into consideration radioactive substances because we cannot play with them. We cannot handle them. So you will study about radioactive substances if you will choose to study chemistry or physics for your master's, for your PhD program. It is also like if you go for a PhD program in physics or maths, maybe you will be able to study radioactive substances. Okay, chalo. So let's talk about hydrides. Let's talk about hydrides. So what are hydrides? Okay, what are hydrides? Hydrides are those substances in which hydrogen is connected to them. It is only them and hydrogen which is present with each other. So hydrogen combines with a large number of species and results in the formation of metals, non-metals, and results in the formation of hydrides. So in any hydride, what you would have is only the substance and hydrogen. So suppose a element E combines with hydrogen, then you will get a hydride. Formula will be EHX, where X can be the number of hydrogen atoms. Okay, X can be the number of hydrogen atoms. Guys, polonium यार polonium radioactive है भाई. Polonium is radioactive. Okay, polonium is radioactive. So we'll not consider radioactive substances while discussing the chemistry of them. So this is a hydride. Now hydrides come under three categories. There are ionic hydrides, there are covalent hydrides, and there are metallic hydrides. What is the general idea behind each and every one of them? Remember, an ionic hydride is formed by group 1 or group 2 metals. They are known as ionic hydrides or saline hydrides. X depends on the valency of, yes, it depends on the valency of E at times. X depends on the valency of E. It could be a polymeric system as well. So mostly on a general note, it will depend on the valency of E. Covalent is when it combines with non-metals. So over here, hydrogen combines with what? Group 1, group 2 metals. Okay, group 1, group 2 metals, and it will form ionic or saline hydrides. If you take non-metals, then you will get covalent hydride. If you take D block metals, and more so from group 3, 4, 5 and 6, group 3, 4, 5 and 6, they will form metallic or interstitial hydrides. Please do remember that metallic or interstitial hydrides are formed by D block elements. So the whole periodic table reacts with hydrogen. The leftmost part, that is the S block, gives ionic. The rightmost part, which is the non-metal part in the P block, that gives covalent hydrides like CH4, NH3, H2O, SiH4. These will be covalent hydrides. And the middle part, which is the transition series. In the transition series, there group 3, group 4, group 5, group 6, they will react with hydrogen to give metallic or interstitial hydrides. Clear? Is that understood? Clear? Please tell me a yes if you have understood this. Halogens, yeah man, halogens are non-metals, na? So halogens are non-metals, all non-metals included over here, or non-metals are included over here. Okay? Is this clear? Is this clear? Pretty easy stuff, pretty basic stuff. You have to understand it as a story, and you have to understand the logic behind each and everything. Only then inorganic chemistry will become easier. If you try to memorize information, if you try to memorize things, your mind will you will start forgetting things. Chalo, cool. So let's discuss a little bit about ionic hydrides. So as I have told you, the ionic hydrides are stoichiometric. So there are certain words that will come up. Ionic hydrides are stoichiometric, which are formed when hydrogen combines with elements of S block, except beryllium. Now beryllium is fairly non-metallic in nature. Beryllium is very small and it is fairly non-metallic in nature. So beryllium hydride is non-metallic hydride. Okay, please do remember, beryllium hydride is a non-metallic hydride. What is stoichiometric? What is the meaning of the word stoichiometric? That means the number of metal and hydrogen will be in a whole number ratio. Okay, so stoichiometric means metal is to hydrogen will be a whole number ratio. For example, sodium hydride, it will be 1:1. Calcium hydride, that is 1:2. So it's a whole number ratio. Understood? Is that clear? HCl is ionic, but HCl is not ionic. HCl is actually covalent. HCl is not ionic. Okay, so ionic nahi bolte. HCl is polar covalent. Okay, so what are the properties of saline hydrides? Saline because they are used. See, there's another important information. Why they are known as saline? What is the most saline thing that is there on earth? What is the most saline thing? Science world, if you're in 9th and you're able to understand this, then it's very nice. What is the most saline thing that is, or which is the most abundant saline thing which is you can see on earth? There are no numericals as such. What is the most abundant saline thing which is which you can find on Earth. What is saline? Sea water, very good. Sea water. Saline refers to salt. Okay, sea water. So most abundant entity which is saline is sea water. In fact, why they are known as saline hydrides? Because sea water, if you electrolyze sea water is also known as brine solution. If you take sea water and you perform electrolysis, you can in fact obtain a lot of elements like sodium, potassium, magnesium, but you have to be very, very careful in designing the process. But these metals can be obtained from seawater, and that is the reason the hydrides of these metals are known as saline hydrides. Okay, they're known as. So is the electronegativity between hydrogen more than 1.7? Obviously it should be more than 1.7. If it is, you can start with chemical bonding before periodicity, but you can do that, but you will not be able to understand radius and all. Ideally, you should do periodic properties first and then start with covalent bonding. Okay, so they are white crystalline solids, have ionic lattices, and they behave like salts. They have high melting and boiling point, and density is higher than that of metal from where it is formed. It is due to the fact that hydride occupy the holes in the lattice. So what is a lattice? A lattice is a three-dimensional arrangement of the metal. So where does the hydrogen sit? The hydrogen will sit in the small spaces which are known as voids. And these voids, if get filled up, it's just like a sponge being water being added to a sponge. Okay, water being added to a sponge. What if you take sponge, a dry sponge, and sponge which is wet, which is more dense? Everything has reactions, man. You have to just make sense of it. Which is more dense, dry sponge or wet sponge? Which will be more dense? Right? Which is more dense? Dry sponge or wet sponge? Wet sponge. Why wet sponge is more dense? Is because water percolates inside the wet sponge. Similarly, hydrogen, if goes inside the lattice of the metal, okay, hydrogen if goes inside the lattice of the metal, what will happen? What will happen is the density of that hydride will increase. Okay, is that understood? Is that understood? The density of an ionic hydride is higher than that of the metal, because so they are going inside. Okay, clear? And thermal stability decreases down the group. Why does the thermal stability decreases down the group? Because the size of the metal increases, so the size of the void also increases, and each void, so if the size of the void increases, then the hydrogen is sitting in there with less attractive interaction, and so it can decrease the moment you heat it, hydrogen can just get lost. If the atoms are small, then the size of void, can you see this empty region is known as void. If the atoms are large, then the size of the void is also large. This is the void. So the void is where these hydrogen atoms are sitting. If the void is larger, then the force of attraction on the hydrogen is lot less, and so this hydrogen can escape quite easily. Okay, clear? So that is the reason the thermal stability decreases down the group. Why I am saying that the void size increases down the group? Because the size of the radius of the atoms increases down the group, isn't it? When you go down the group, so from sodium to cesium, the radius of the atoms increases. And if the radius of the atoms, radius of the ions increases, the size of the void will also increase. And the hydrogen which is sitting in the void is not under a huge attractive interaction as it was happening earlier in a smaller void. And so if you heat it, hydrogen will get liberated. Anurag, you should first do hydrogen. Okay. Covalent hydraides. What are covalent hydraides? Covalent hydraides are also known as molecular hydraides. They are formed by covalent. They are formed by elements which are non-metallic in nature. Okay, which are non-metallic in nature. So most common are CH4, H2O, NH3. Now all these hydraides, okay, all these hydraides are divided into these categories. Covalent hydraides are divided into these categories. Electron deficient, for example, BH3. BH3 in fact doesn't exist. BH3 exists as B2H6 or BeH2. This has 6 electrons in valence shell. This has 4 electrons in valence shell after formation of bond. So they are electron deficient molecular hydrides. Okay, electron deficient molecular hydrides. Electron deficient molecular hydrides. Clear? Electron precise. Electron precise is like which have exactly octet. Exactly octet and not more electrons, not unshared pair of electrons. CH4, SiH4. These have exactly octet and they are the octet of the central atom is octet of central atom is achieved, and there are no extra electrons for donation, but there are electron rich hydrides like H2O which have OH2 or H2O. You can write it as OH2 or H2O. There are 2 lone pair of electrons. In NH3 you have 1 lone pair of electron. So this is known as a electron rich hydride. Okay? Electron rich hydride, electron precise. This electron rich, electron precise, electron deficient is dependent on what is the nature of the central atom. The nature of the central atom in boron B2H6 or BeH2 is that they are electron deficient. So it becomes an electron deficient hydride. Electron precise, exactly 8, no excess electron to be donated. Electron rich, exactly 8, but there are excess electrons which can be donated in the form of lone pair. Okay, clear? Is this understood? What is covalent hydride? It's pretty easy. We do not have to like dig deeper than this. This is gonna take care of everything. And what are interstitial hydrides? What are interstitial hydrides? Interstitial hydrides are those hydrides which are formed by elements of D block. Which are formed by elements of D block, or which are formed by, you should first do GOC. Okay, we'll talk a little later. Let's finish this and then we can talk. So interstitial hydrides, these hydrides are the ones which are formed by D block elements. Please do remember that interstitial hydrides, okay, interstitial hydrides are formed by only group 3, 4, 5 and 6 group elements. 3, 4, 5 and 6 will form. Okay. Electron precise means exactly octet, no more, no less. Excess electrons are not present in the form of lone pair. In group 6 only chromium forms hydride. Few important points. 7, 8 and 9 do not form hydrides, and this is known as a hydride gap. 7, group 7 contains manganese, group 8 contains iron, group 9 contains iron, cobalt. Okay, so 7, 8, 9, they are present in group 7, 8 and 9, and they do not form hydrides, and that's known as the hydride gap. Earlier it was thought that the hydrogen atom, being small, occupies some interstitial sites. Except for this, other hydrides are formed to have lattice different from the parent metal. A most important feature is that they form non-stoichiometric. Can you see this? This is non-stoichiometric. Non-stoichiometric means the metal and the hydrogen are in a non-whole number ratio. They are in non-whole number ratio. Is that clear? They are present in non-whole number ratio. The composition, so the composition is a little disrupted. The reason is when hydrogen comes inside the metallic lattice, then it distorts the lattice, some atoms are lost from it, and so the ratio is no longer a whole number. Okay, the ratio is no longer a whole number. The most important application of interstitial hydride is its ability to, like, if I want to transport hydrogen, you might have seen this hydrogen balloon. Okay, you might have seen a hydrogen balloon, or at a fair, a cylinder from which a person gives you a hydrogen balloon. Okay, so a hydrogen cylinder, if you shake it a bit, then you will find that it seems like there is some sand which is present at the bottom of it. What is that compound? Okay, what is that compound? What is that sand? If you ever try it out, it feels like there's some sand in it. That is a metallic hydride which is present. This metallic hydride is a effective way of transporting hydrogen. Metallic hydride is an effective way. Can you see this picture? This is a metallic hydride tank. It is an effective way of transporting hydrogen. You take this metallic hydride powder and heat it, and you can obtain hydrogen. Sir, hydrides are variable. There's nothing like variable. It's the same. Like, where is the variable? I don't understand what is the meaning of variable that you are saying. Okay, so please do remember that the hydrogen topic is very simple. You learn about preparation, few reactions and hydrides. That ends the topic of hydrogen. Okay, that ends the topic of hydrogen. In tomorrow's class, we will discuss about a compound of hydrogen, that is water, and if time permits, about hydrogen peroxide. Okay, so please do remember to join us tomorrow. I hope you have understood everything that has been taught today. Hydrogen is a very simple topic. In tomorrow's class, we will discuss water and hydrogen peroxide, and the class after it, if everything goes fine. Okay, so when we heat the metal, what happens to the metal? The metal remains like that, man. So hydrogen is trapped inside the metal. Okay, it's just like you keep the sponge in the sun. Sponge will not get destroyed. Sponge will remain like that. Water will go out as water vapor. Okay. On an average, how can we do P blocks, sir? You have to remember specific sections. Okay, that is most that you can do. GOC is the first thing that you should do, man. Before GOC, you shouldn't do hydrocarbon or you'll not understand anything. No, Harsh Chauhan, this 1.5, this law of constant proportion is not holding true over there. These compounds do not follow that law. Okay, it depends on the extent to which hydrogen is trapped inside the sample, to which extent the lattice is distorted, and because of that these numbers come up. This is always because of deformity. Okay, these fractions that you are seeing is always because of deformity of some sort. Okay, fine. So I hope you enjoyed today's session. Though there were less number of people, please do come tomorrow, because we'll be discussing water and hydrogen peroxide, and water and hydrogen peroxide are important, and that will finish the whole topic of hydrogen. Once that topic is done, we will devote one class for discussing questions, discussing multiple choice questions, previous year's questions, and so that is how we will be doing every topic. We will take some time to cover theory, and then we'll take some time to cover problems. Will I do one shot videos? Man, uh, let's see if time permits. ठीक है, चलो, bye bye guys, have a lovely time, and please please don't ignore your health. Please be safe, please drink a lot of water, and what else, please do come tomorrow. Like, share and subscribe, ये तो आपको मालूम ही है. And please do come tomorrow, because we'll be doing water and hydrogen peroxide. ठीक है, चलो, bye bye guys, have a lovely time.